Hey there, everybody. Welcome back. This is section 13.2 in Calculus 3. We're looking at limits and continuity in multivariable functions. The last video showed doing the delta epsilon proof in two-space. For those of you that didn't learn about it in Calc 1, I wanted to include the following information. I have some resources in our Canvas section. And then if you look in the announcements, there's a section or one called Delta Epsilon Proof. There's a good website by Milefoot that walks through how to do these and gives a couple examples, including nonlinear functions like x squared, that we got a quadratic there. Some weird functions like this. And then I also put some video resources in. There's a couple from Krista King that had a good description of it, showed how to do the graphical representation of delta epsilon pretty well. And then there's a YouTube gentleman goes by Just Calculus. It's supposed to say Just Calculus. I thought it was Just Calculus. Yeah, it says Just Calculus. Maybe change his name. He's got several videos here that are pretty good, showing different delta epsilon proofs. Again, these are in 2 dimensions. We're here to do 3 dimensions. So let's take a look at that. Recall that the 2-dimensional delta epsilon proof, we were looking at a distance from L that we called epsilon. And we wanted a distance from A, x equals A, called delta. When we upgrade this to 3 dimensions, we want to include that same idea. It's distance related. So if we're looking at the definition as the limit is xy goes to x naught, y naught, for f of xy equals some limit L, this means the value of f of xy can be made as close to L as we'd like by restricting the point xy to be sufficiently close. But it doesn't need to be equal to x naught, y naught. And by sufficiently close, we mean distance. What's distance in more than one variable? It's that square root function. So for all epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than x minus x naught squared plus y minus y naught squared, that quantity, the square root thereof, that is less than delta. That implies that f of xy minus L is less than epsilon. This is the distance version, whereas absolute value was the distance version when we just had one variable in there. So I wanted to show you guys a picture real quick before we look at an example. Get a better idea of what that means. Oop. Pulled too much. Where is it here? There it is. So we've got some surface here. We've got some point here. This curve doesn't show well, but the L minus epsilon is anywhere along this border. And that's going to generate a distance delta in the XY plane down below. Okay, so we have a distance delta down here, and it's doing some radius right there. That's why we have the square root of x minus x naught squared plus y minus y naught squared. Again, we're trying to show that any path, no matter what path we take, we get to the same limit. Okay, let me bring that back over and we'll take a look at an example. We want to do the limit of xy approaching the origin of 3x squared y over x squared plus y squared equals 0. So let's do our delta epsilon proof. We're following this up here. Our origin is our point that we're going to, so x naught and y naught are both 0. And we've got that here. If 0 is less than x minus x, or x squared plus y squared, I'm sorry, if 0 is less than the square root of x squared plus y squared, and that's less than delta, that implies that's 3x squared y over x squared plus y squared. At least the absolute value of is less than epsilon. Notice that the 3x squared is positive, as is the x squared plus y squared. They can come outside of the function or the absolute value. So we have 3x squared over x squared plus y squared. Absolute value of y is less than epsilon. And now we're going to take a look at the following interesting little trait. Since x squared and y squared are both greater than 0 or equal to 0, then this portion we have right here without the 3, x squared over x squared plus y squared has to be less than or equal to 1. Like it's equal to 1 if y squared equals 0, like y equals 0. And then if y doesn't equal 0, the bottom is always going to be bigger than the top, and therefore the denominator is bigger than the numerator, and we have a fraction less than 1. Which means we can say, well, the absolute value of 3x squared over x squared plus y squared, the absolute value of y times the absolute value of y, that's got to be just less than 3 times the absolute value of y. And we'll make sure that's less than epsilon. Okay. So we'll divide by this and we'll see the absolute value of y is epsilon over 3. But that's not what we want. We don't want the absolute value of y, so we turn it into the distance formula. We got 3 square root of y squared. That's the absolute value of y, technically. We know that's less than the square root of x squared plus y squared, because x squared is at least 0 or larger. So this, well, we should put less than or equal to. Is less than, and that's less than epsilon. So we're going to just pick delta to be less than epsilon over 3, which happens when we divide this by 3. Okay. So that gets us to our proof. As a reminder, this is what we're proving. Let epsilon greater than 0 be given. For all epsilon greater than 0, there exists a delta greater than 0 such that 0 being less than the square root of x squared plus y squared being less than delta implies that 3x squared y over x squared plus y squared is less than epsilon. We don't have anything in here because minus L is minus 0. We're going to start from the left and prove the right, get to the right. We define delta to be epsilon over 3. And we go with the proof. We start with epsilon over 3. We multiply by 3. Oh, first we show that x squared plus y squared is just greater than y squared. Square root, sorry, the square roots of these. And that's still less than epsilon over 3. So then we multiply by 3. And we get 3 square root of y squared is less than epsilon. But we know 3 square root of y squared is actually greater than x squared over x squared plus y squared multiplied by 3 absolute value of y, because this number is, this is less than 1. So we're reducing it. And then we move these inside the absolute value. We move the 3 inside the absolute value, and we have the absolute value of 3x squared y over x squared plus y squared is less than epsilon. And then we proved it. Okay. That's it for the delta epsilon. I didn't want to dive into it too much. The point is that it exists. If you want to learn more about this, you can look stuff up on the internet or take a real analysis class when you transfer. Real analysis, you will do lots of proofs. A lot. I didn't care for it myself. I liked applied mathematics. Ooh, that's not what we want. But most of the teachers at our school are pure mathematicians, not applied math like myself. And they really love this stuff, so I'm sure they give a better presentation on delta epsilon. Peace.